Howdy, howdy, Year 7s. We've got another experiment, making your own compass. Some of you might have attempted this when we had National Science Week. This was an optional activity. If you do have a magnet at home and a large nail, why not maybe try it out yourself? Okay, so it says take a large nail and stroke it with a strong permanent magnet. After each stroke, lift the magnet high above the nail before commencing the next one. You need to make sure that each stroke is in the same direction and made with the same end of the magnet. After a total of 40 strokes, test your new magnet by trying to attract paper clips. So I've still got my north from the other experiment we did. Iron nail and my magnet. My north is pointing towards the iron nail. Now I have to swipe it 40 times. Now remember we talked about domains, so think about the domains. If my magnet is pointing north and it's travelling along the nail, think about what end this might be. What end's the pointy end? There's my north. What's going to be attracted to north? So what's my pointy end going to be? Now we need to test it with a few paper clips. So it's definitely magnetic. Okay, remember. So our north is pointing that way. My nail. So it's definitely magnetised. So remember north. I've just got a tiny, I've just cut a cup, a styrofoam cup, just so it's got something to float, because otherwise if I put the big heavy nail in the water, it's going to sink to the bottom. So I've just got the styrofoam to help it float. We do think north is that way. So I'll put the nail completely different. Just sit it in there. I've got to get it to balance first. There we go. See what happens. Oops, sorry, there's metal near the compass. And then that nail's gonna also affect it. How are we looking? Pointing in the same direction? The next dot point says compare the strength of your magnet with others in the class. We can't do that one. But it did attract a paperclip. First question. So I don't need you to write this up like an experiment. You can just put the heading. So make your own compass and then answer the questions. So the first question is your magnet a permanent magnet or a temporary magnet? Now we've done some theory on that. If you can't remember, maybe go back and read your class notes about permanent and temporary magnets. Think about the experiment that you did, magnets, and more magnets. Then question 2, which end of your magnet is the North Pole? How do you know? Might help to draw a diagram here. Think about the way that I ran the magnet along the nail. Also think back to our compass and how our nail is positioned. Which way is the pointy end facing? Which way is the large end facing? The head of the nail. Remember the notes that you read about destroying a magnet? So things like hammering it, hitting it, dropping it can just disrupt the domains. They'll jumble up and then you won't have a magnet anymore. It does say try this experiment using a sewing needle instead of an iron nail and without using the float. All right, I'm going to try for you. I've just run the magnet along the iron nail 40 times, like this. So think about what the pointy end might be, if that's my north. Now this is a hard bit. I'm just trying to think, no, I want it the other way. Okay, so there's the needle floating. Remember north. And that's the pointy end, remember? Why is it floating on top of the water? Why didn't it sink like the iron nail? What is going on? Big thank you to Professor Bones for conducting the experiment and helping me out. All right, good luck. See you, bye.